purpose of this. The grid is basically focused on integration of infrastructure of a community for let me highlight it, for collaboration, sharing, resource execution, resource sharing, or resource extension. By extension means here means for example, I have 5 computers to run my code, and I need 500 computers, so I can extend my resources by using grid and use the idle resources on the net, so my computation capacity will increase drastically. But the cloud is for business purposes. So the main purpose in cloud is on-demand extension of local elementary services. For example, we may use backup or infrastructure as service, as I told you before. For example, this is what we have as VM allocation. So we can rent a virtual machine on the net, and we use that. Also, we have PaaS and SaaS, as you may recall these two technologies as I discussed them in details in the previous session. So cloud basically focused on demand extension. On demand means according to requests. When a request arrives, we can scale up. And then we have this model that I told you before, which is called pay as use. Okay, in cloud, you pay according to the usage. How much resources have you been using? Then you will pay for that much. Okay, so origin of these two technologies. The origin of grid computing is from academic community, as you can see here, from 1998. Basically, we refer grid to the work of Dr. Jan Foster and Dr. Kesselman, and the work was the title of their work was the anatomy of the grid. I think it's a well-known paper that introduces the grid technology, and you can see it online. Let me share the link to it. Just a second. Okay, you can see this paper here. You can use the link in the chat box to download the paper that introduced the grid. But the origin of cloud computing is in 2003, and in 2005, the cloud was well known, and everyone talks about it in that era. So the beginning of cloud is about 5 to 7 years after the grid. And also we know IBM and Cisco and maybe Microsoft and Apple as the basic supporters of this technology. Also, the community shifted toward this model, cloud computing model. So we have this commercial prefix when we talk about cloud. You know, we want to make money when we think about cloud computing and cloud-based providing of services. Okay, so the base is making money and commercial, but in grid, our intention is basically towards academic people, academic community. Okay, we want to do scientific stuff here in grid, But in cloud, we want to make money. We talk about business. The basic foundation of cloud is for profit, for making money. So they have two different origins, as you can see. Okay, let's. Is there any question? Is there any question? Can you hear me, guys? Is there any question? Okay. The name of grid came from power grid. Okay, power grid is the electrical network of wires and posts and dispatching centers, which allow you to have access to electrical power without extra effort. Okay, you plug in your device on the outlet on the wall, and you turn that device on, and the electrical power will reach your device, and you don't know where it basically comes from. Okay, so you want to turn on your TV, you just need to plug the cable and turn it on. Okay, this is the promise of power grid. Okay, and in grid computing, the designers and the basic idea providers like Dr. Foster wanted to mimic this behavior. They wanted to allow the users to have access to unlimited computation power as they may experience some lack of enough computational power in their project, in their research. So they can, for example, push a button and then their task will be transferred to a noun, and then the result will be summed up and will return to their computer, to the final user, to the end user. Okay, this is the promise of grid. So the name came from power grid. And about cloud, every time before we have this term grid cloud, everyone we wanted to show the internet. The internet usually let me draw it here as a cloud like this. Okay, and we write in the middle of this shape, this thing, internet. Okay. Okay, and now when we say cloud, we mean this depiction, this exact depiction of internet. So in cloud, we want to tell our customers that this kind of service is internet-based service. Everything will go on the internet, and you don't need to worry about anything else. You just pay the price, and then you can have access to resources or services you may want. This is the name origin of cloud and grid. And about business model, in grid there aren't any specific business model at the beginning of the project. Everyone were focused on academic aspect of grid, how this technology can help different universities and researchers to conduct their research by providing adequate computational power and storage and everything like that. So the business model in Grid is informal course, and usually we have this basic definition of virtual organization in the Grid, which allows to classify and group different kind of users and assign different security policies and monetary policies and different things. But this model was informal and coarse. The Grid origin is from academic sector. So from the beginning, we don't intend any profits, and so the business model was not mature enough and never got to that maturity that cloud has at the beginning even. Okay, so the business model drastically differs from the cloud. And for cloud computing, we have this flexible model, which is called pay as use. So you pay as much as you use the resources. For example, you may rent a CPU for 100 minutes, or they use 100 CPUs for 1 minute. This is usually equal, at least on the paper, okay, theoretically. So this is very promising. This is very promising even today. We want to use this model because it helps us to pay according to the usage and escape extra fees and extra payments, especially when we are talking about, for example, immature businesses like startups. Okay. So we have a question here: is cloud centralized system? Okay, no. The short answer here is no. Excuse me, just a second. Excuse me, guys. So yes, I will discuss this important question. Dear Rasha Samad asked a question about diversity of Grid, and dear Asma Sami asked about this is cloud centralized system. Okay, let's talk about these two important questions because they shape our discussions. Let me bring you something here which will help us to be more illustrative. Just a second, and I show you an image. Just a second, guys. I want to share an image with you. Can you see the image? Guys, can you see anything? Because it's blank for me. Now it's loaded for me. Can you see it? Okay. So, think about this. We are the end users. For example, this is me. This is you. This is, for example, dear Rasha Sarma. This is, for example, dear Fanas Muhammad. This is dear Ali Abdul Karim, dear Safaf Ayat, okay, different users in the class. We may live in different countries or cities, or even we may be near each other. For example, these users are near each other. For example, they are in class. But we may have different customers around the world. So end users may disperse around the world. For example, everyone knows Dropbox, okay? Dropbox, or Google Drive, or let me say Google Docs. Okay, the users of these technologies, these services, are dispersed around the world. For example, some of them are in Asia, some of them are in North America, some of them are in Europe, and everywhere around the world. So we have full distribution in the end user layer. Okay, dear Asma Sami, we have full distribution of users, end users in cloud. Okay, so this layer, this end user layer, is fully distributed. Okay, you agree with me? Let's go to this is front end. This is front end. And then we have this back end where all the servers are there. For example, let me tell you about this back end. Okay, what is exactly in the back end? I don't know if you can see it or not, because the image has not a good quality, but let me draw it. It's better to draw it. Just a second. Let me show you an empty image and draw for you. Okay, so what is exactly in a cloud data center? This is a very important question. For example, we have this data center 1. For example, let me name it, the data center in Tehran, okay? This is our first data center in Tehran. What is really inside a data center? In data centers, we have different clusters, okay? Different clusters of computers. For example, here, we may have 300 computers, servers. Here we have 500 servers. Here we have 200 servers. Here we have 120 servers. Okay, so for example, we have near 1,000 of servers here, and these let me change the color. And these clusters are connected through some I don't know, switch, a router, or everything they may use to connect these together. Let me change the color again. Okay, this is the connections, and this router or different levels of switch is connected to internet backbone, for example, multiple fiber optic links, internet backbone. Okay, and this is a data center. This is a hypothetical data center we have here, our data center in Tehran. Okay. So as you can see, we have multiple clusters. Okay, each one is a cluster here. This is a cluster. This one 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 is cluster. And we all know that clusters are distributed cluster computing. For example, here we have 4 different clusters. So we have different 4 classes of computers connected to each other. So a data center is data. Let me write it for you to help you to be more okay. A data center is a distributed computing center, which basically consists from different or many clusters. What happened? Basically consists from many clusters of and each cluster may have many hundreds of servers. Okay, so we can say cloud computing is absolutely a distributed computing model. First, at the end user layer, all users are dispersed around the world. Okay, and then in the data center layer, in the backend, we have different clusters connected to each other. Okay, I think this image will help you to understand the organization of a cloud data center. Okay, let's proceed to the next question. Data centers is the same virtual? No. This is a real data center. This is real data center. Then you can use virtualization. For example, let me discuss in more details. Okay, let me bring you another slide. Let me bring you another. Let me create you another slide because this one is incapable. Okay, as you may recall, I told you inside a cluster, we have different computers, yes? For example, this is a cluster. With 200 servers, okay? And this is a server here, okay? This is a server. Okay. So we have 200 of these dots, which are basically our servers. One here, one here, one here, and 200 of them. Okay. So on each, and we call each of these computers a physical server or a physical host. Then we can install, for example, we may use a virtual machine, VMware, I want to type this because it helps you to learn better. We install, for example, VMware, Zen, or any other technology on each a physical host, and then we can let me we can have multiple virtual machines on each physical machine. What does that mean? Oh, what happened? So we can install a VMware on each machine. So uh, on each physical host, we may have, if this is a physical host, we can have different virtual machines. For example, let me write it for you. Windows Server 2012 virtual machine. Have it here. And also Ubuntu. Ubuntu server here. Or a Red Hat server VM here. Another Windows server VM here. Okay. On each physical host, we can have, oh, what is this? We can have different virtual machines. And this is virtualization technology, which I will discuss later. For example, if this is a physical host. So in this physical host, we have 1, 2, 3, and 4 virtual machines. Okay, let me write it for you here. We have 4 virtual machines on a single physical server or physical host. Yeah, dear Fanas Mohammed, Ubuntu is a Linux distro. Red Hat is a Linux distro. Yes, of course, we need firewalls and different storage devices to protect our network and to dispatch loads. And we may need different security measures. For example, we may install UTM devices. So, dear Asma Sami, is it clear now for you? And dear Rasha Sarmad, you asked about virtualization and virtual data centers. Now I think you know what the virtualization really means. Okay. I hope this helped you to understand the basics of this technology. Okay, let's go back to our slides. Now, um, let me change the color. Okay. So in cloud, we have this business model, which is called pay as you use, and you can pay according to your usage. But in Grid, we don't have any specific business model. I know there are lots of work out there in the academic communities regarding the commercialization of Grid, but none of them is successful. So we can say firmly that grid computing is not has not a firm or reliable business model. If you want to make money, if you want profit, if you are a commercial person, if you want to start a business, then you are talking about cloud, not grid. Okay, grid is not a commercial technology, although there are lots of work around this. Okay, collaboration support. Uh, in Grid, collaboration is the basis of the technology. So yes, Grid supports collaboration in its core, and the collaboration is the basis of Grid technologies. But cloud, as it's a commercial technology, then collaboration is not fully understandable in commercial ecosystems. But now we have this thing called, let me type it for you, federation. Okay, cloud federation. It's a good topic for your research and your thesis if you want to. Uh, Cloud federation is basically around the concept of collaboration. Okay, and in cloud federation, we discussed the possibility of transferring loads on an over crowded data center to another friend data center or business partner. Okay, so now we cannot say that there is no collaboration support in cloud. Yes, of course, for load balancing uh, and uh, and delivering better user experience to end users and preventing, for example, things like tail drop. You know, tail drop. Tail drop means when a customer sees a drop in the quality, he sees a long queue in front of him, then he may decide to drop his request and switch to another provider. This is a very unpleasant experience for cloud providers. So we may use Cloud Federation to provide better collaboration support to our customers. Is there any question? Okay, let me roll back this part. And about homogenization of resources. In Grid, we support full heterogeneous resource sharing. We computer. Okay, this is so easy in cloud because basically, cloud supports for virtual machines, and virtual machines help us to have access to different types of architectures, instruction sets, and different machines, basically different machines. But we should say that mostly Linux is being used in cloud computing services. I mean, yes, this is yes, because I told you before. When we talk about providing virtual machines, then we are talking about yes. Also, when we talk about PaaS, for example, when we talk about Microsoft Azure, you have access to different platform neutral services. So we have this support for heterogeneity in PaaS model. Also in SaaS, for example, many of you may use Google Docs or Gmail. Okay, Gmail doesn't care about your browser, your computer, your the architecture of your hardware. Okay, you just want to use Google Docs. You can or Gmail. You can log into it with your browser. Okay, everything else it doesn't. Everything else uh, is not related to the concept because it basically doesn't interfere with our connection with that service. So cloud computing supports heterogeneity uh, in all three basic models: in IaaS through virtualization, in PaaS, and in SaaS. Okay. So yes, grid and cloud supports heterogeneity in their core. Okay, is there any question here? Is there anything that needs to be discussed with more details or more examples? Okay, perfect. That's very nice. What do you mean by hybrid? By hybrid, we mean private and public clouds. Okay, let me show you this slide to help you remember this. Yes, public, private, and hybrid. Hybrid cloud is a type of cloud which has its private customers or users. For example, Google has its own staff. Okay, so it provides them with a private cloud, and also we are all customers of Google, so we are on the public sector of that. We can use both on-premise and cloud in hybrid. I don't fully get your sentence. Can you rephrase it? Okay, please, dear Fanas Mohammed, please write your question, rephrase your question so I can understand you. Let's have a break, and after break, we can have the presentations. After break, I will try to answer your question. If you please write it with more explanation, I will return to your question after a quick break. Okay, dear Rasha Sarmad, who is going to present first? Dear Khalid Jamal. Okay, okay. I will open Khalid Jamal. Dear Khalid Jamil, you have access to microphone and also you can upload PDF files if you want to. Now let's return to dear Fanas Muhammad's question. A main hybrid cloud refers to mixed computing, storage, and services environment made of on-premise and on-premises, okay, private cloud services in the public, such as Amazon Web Services and Microsoft.
السلام عليكم.
Okay, what's the question? It was not the question. Dr. Just I wanted to share this info from. Okay. Okay, thank you. Thank you for your explanation, dear Fanas Muhammad. Uh, okay. Uh, dear Khaled Jamil, can you talk again?
Yes, دكتور.
Hello. How are you? Salamun alaikum. Uh,
وعليكم السلام
so
ورحمة الله دكتور.
can you upload your files?
أوكي دكتور.
Dear Khaled Jamil, what happened? Do we have any problem with the system?
دكتور ده upload I upload to computer.
Okay. Yes, dear Rasha Sarmad, I open your sharing permission. Now you can share. Okay.
اوكي.
Perfect. Okay, dear Khalid Jamil, we can have your presentation. Please start.
ثانك يو دكتور. السلام عليكم everybody. بسم الله الرحمن الرحيم. الموضوع طبعا بلوك تشين، فد نبدا مختصره عليه. ممكن ست رشا السلايد الثاني. ست رشا. البلوك تشين طبعا راح نبدي بتاريخ سلسله ان فكره البلوك تشين وظهوره ظهرت وتم وصفها بشكل مبكر بدايه التسعينات، وذلك من خلال الباحثان سكوت وستيوارت الذين قاما بتقديم حلول عمليه وحسابيه لوضع ختم للمستندات الرقميه بهدف عدم السماح لاحد بالوصول اليها او التلاعب بها او تغييرها. على الرغم من ذلك تلاشت هذه التكنولوجيا ولم تعد مستخدمه حتى عام 2014، حيث دخلت بمفهوم جديد ومتطور التي تسمح للمستخدمين بكتابه عقود ذكيه اكثر تطورا، وبالتالي انشاء فواتير التي تدفع لنفسها عند الوصول شحنه جديده او تبادل شهادات مع المستخدمين، وترسل طبعا تلقائيا الى اصحابها. ممكن ست رشا الصفحه الثانيه. هنا ناخذ تعريف سلسله الكتل. هي قاعده بيانات موزعه تمتاز بقدرتها على اداره قائمه متزايده باستمرار من السجلات المسماة كتلا، تحتوي كل كتله على الطابع الزمني ورابط الكتله السابقه. صممت سلسله الكتل بحيث يمكنها المحافظه على البيانات المخزونه بها والحيلوله دون تعديلها، لذا هي امنه حسب التصميم، وهي مثال على توزيع نظام حوسبي موزع ذو سماحيه بتحقيق نظام توافقي في الاراء، اي تكون لا مركزيه بحته. الصفحه الثانيه. ممكن الصفحه الثانيه. المكونات الرئيسيه في البلوك تشين. طبعا تكون البلوك تشين من عده مكونات، بس راح ناخذ الاشياء الرئيسيه بها. دفتر القيد او السجل، وهو نظام موزع السجلات عبر شبكه الاعمال، يوفر رؤيه المعاملات لكافه المشاركين المعنيين بها. اثنين، العقد الذكي، وشروط شروط العمل او الخدمه المذكوره في قاعده بيانات المعامله لضمان تنفيذ الشروط المناسبه او الالتزامات المناسبه طبقا لكل معامله. ثلاثه، الخصوصيه، تعتبر المعاملات موثوقه ويمكن التحقق منها من اطراف المعامله فقط. اربعه، الثقه، يتم اعتماد المعاملات من قبل جميع المشاركين ذوي الصله. اخيرا، الشفافيه، جميع المشاركين في الشبكه على علم بجميع المعاملات التي تؤثر عليهم، وهذا راح يكون طبعا هي الشفافيه. 16 صفحه ثانيه. سايت كيف تعمل تقنية البلوك تشين. ما أعرف أنا الصورة عندكم ولا لا. طبعا كيف تعمل تقنية البلوك تشين؟ البلوك تشين عبارة عن سجل مركزي لجميع المعاملات عبر الشبكة، عبر شبكة أجهزة مرتبطة ببعضها، وتسمى بتقنية الند. واستخدام هذه التقنية يمكن للمشاركين تأكيد المعاملات دون الحاجة إلى سلطة تصديق مركزية، ويتم توزيع المعاملات المطلوبة وبثها على شبكة الأجهزة المرتبطة ببعضها البعض، وتقوم شبكة الأجهزة بالتحقق من صحة المعاملة المطلوبة وأحالة هذه المعاملة باستخدام خوارزميات ويتم ربطها بجميع المعاملات السابقة وإنشاء جديدة بمجرد التحقق من صحة المعاملة. يتم ربط الكتلة الجديدة بسلسلة الكتل الموجودة سابقا بطريقة دائمية وغير قابلة للتعديل. السلايد الثاني. هذا المخطط يمثل خطوات العمل البلوك تشين من البداية حتى تكون عندك المعاملة. السلايد اللي بعده 16. السلايد اللي بعده طبعا هو الفوائد المحتملة للبلوك تشين. طبعا هي توفر البلوك تشين بطبيعته يوفر الوقت، ويتم تقليل وقت المعاملة من أيام إلى معاملات شبه فورية. 2 خفض التكلفة، أي تكون النفقات الإدارية وتكاليف الوسطاء تكون قليلة أو تكون معدومة أو إلغائها. تعزيز وجود البيانات ويتم الحفاظ على دقة البيانات مع جميع المعاملات. خفض المخاطرة، تنخفض نسبة التعثر أو الغش أو الوقوع ضحية الجرائم الكمبيوترية. أخيرا طبعا هي زيادة الثقة، جميع السجلات محفوظة وتكون مرئية لجميع الأطراف المعنية بالمعاملة، وهذا طبعا راح يقلل من المنازعات وتكون أكثر شفافية. أهم استخدامات البلوك تشين. أهم استخدامات البلوك تشين معالجة المدفوعات والتحويلات المالية، عمل نسخة احتياطية للبيانات وتكون غير قابلة للتغيير، الحفاظ على السجلات الطبية، حماية الملكية الفكرية، التصويت الإلكتروني، والعمليات الاستثمارية المالية. اللي بعد 16. هذا مال الصورة ما تطلع عندي، يعني طلعت خلاص ولا لا؟ شكرا. الخلاصة طبعا الموضوع تكتشين تمثل ثورة جديدة في العالم ومستقبل نحو عالم مشرق. فخلال الفترة الماضية أثبتت جدارة قدرة تحمل الاختبارات والاستمرار في التواجد، ومع مرور الوقت يزداد عدد مستخدميها، وهذا بالضرورة يعمل في صالح استمرارها. وفي المستقبل وفي النظام يحمل نظرة جديدة لأشياء قديمة وتتجاوز، تكون تكنولوجيا شاملة يمكن الاعتماد عليها لإنشاء نظام تكنولوجي متكامل كنظام الإنترنت الذي نستخدمه الآن أو اعتدنا عليه. طبعا احنا عندنا الصفحة الأخيرة هي المصادر اللي سحبتها من أداة الإنشاء. شكرا لكل الاستماع لي. شكرا دكتور علي.
Well, thank you for your presentation, and also thank you, Raja Samad, for your help. Can you tell me who next? Okay. Okay. Dear Farah Ali, you can test your microphone. Okay, now, and you have presentation privilege. Please test, dear Farah Ali, please test your microphone. I don't know, can anyone help? Oh, okay, yes. Someone to help dear Farah Ali, but it seems that now the microphone icon is changing. So let's wait. Okay, now we have your voice, I think. Can you
Hello,
talk?
Doctor.
Hello. I hope you're doing well. So you want to upload your PDF files or not?
Yes, Doctor.
Okay, so start.
Okay.
Dear Farah Ali, why don't you start? Yes, I gave her the permission to use microphone. Let me retry. You know, she has a permission. I don't know what to use microphone. Usually the microphone icon. Yeah, Farah Ali, what's the problem? Can you tell? You don't have voice.
I draw up the virtual assistant with smart door lock, air quality control, healthcare device, and wearable watch, smart car, smart doorables, smart refrigerators, smart sleep takers. Technology consists of four main things. Number one, the device which consists of sensor, sends data about the device and transmits and through the internet. The internet. Number two, the internet. Three, the platform where this data is stored, analyzed, and processed. For the offer and at this stage, we present this thing of the user clearly as the decision maker. The main goal of the Internet of the Things is to factory discussion making, especially for manager and mean different fields such as healthy and the environment. The Internet of Things save offer time and money and return increase productivity and the level of the thing. Thus, making the right discussion leads to better service for constant. Where we note that data science and artificial intelligence are a key part of the internet thing. That data science is sense stabilized data storing, and artificial intelligence is techno smart human intelligence of data storage as basic. school to have to enter the world of internet stuff. The school person has to have to enter this world are many because this area is so wide, but there are some basic skill. The ability to plan, design ability, or having a goal and insisting on implementing it. The machine of action of the Internet of Things. It starts with sensor that starts collection data from their environments and this data is sent called hack network support service provide different service to individuals and combines were censored and connected to server in different ways that me from smartphone, state utilities, Wi-Fi, wireless, internet, Bluetooth, and more. The most important smart equipment in the Internet of Things. One of the most important smart equipment used and interacted with by many of us every day. Internet connected smartphone, which has many sensors such as accumulator. Um, the drawbacks are plans, keeping device GPS and sometime at a heart rate more but this is only every small part of the Internet of Things. Personal as for personal as there are wearable devices such as fitness or heart more thing where phone are used instead to send receive data. For example, smartwatches such as Apple Watch and Bubble accomplish this take more by pairing with your phone. IoT device application used in home. One of the most important application used in home. Their most states water heater, security camera, or lights. This device calculates data and remotely connects to the it to their distance and connect to the internet where is a problem. Some of them are able learn a set of from over time, and then they can change their setting or alert you when something sudden happens. The capability of some IO advice, some smart advice
Dear
can
Fahri, do you want to continue in Arabic? Do you want to continue in Arabic?
no, Doctor.
Because I think it will help you to focus on the content, okay? instead of being worrying about English. I think you can continue in Arabic to be more productive and to transfer more content to the students. But it's your choice. If you want to continue in English, it's okay with me.
Okay.
Well, what will you do? Dear Farahali, what are you going to do?
Yes, Victor.
You want to continue in Arabic or English?
English.
Okay, continue, please. Okay.
Cars and I auto advise. Cars are also smart. For example, GPS has been in the car for years, and we have had few biometric cards that are when passing also to toll situation, and now we have but and add a new functional computer doctors for ultimate car ultimate or ultimate car smart cars can cut as mobile information and internet provides Wi-Fi single to other device and tracking that their driving including speed and full. The, the application and medical care, there are already many advice in use in the area of healthy care, many which are centrally under construction. For example, a doctor or healthy um, will be able monitor. Other business there are for more smart device used in other industries and business where more think without the need for works can save a lot of time and money. GE has tested several sensor for use in camera mixing for variety manufacturing. Thank you.
Okay. Thank you. Dear Rasha Samad, can you send me a message in WhatsApp? Please send me, for example, a dot message, because I want to find your contact. I want to send you some information. Please send me a message. And who is going to present next? And dear Rasha Samad, you want to upload the slides again or not? Dear Yunus Sayyah, you have the permission to use microphone. Please activate your microphone. And dear Rasha Samad, you can upload. And dear Raja Samad, please send me a message in WhatsApp, because I have two different contacts from you. I don't know which one is your own contact. Please send me a message. Thank you. Okay, dear Yunusaya, I see that you're trying to activate your microphone, so we are waiting for you to start. Dear Yunusaya, you have the privilege for microphone, but you should click on the microphone icon, so you will be able to talk. Let me lock you and unlock you. Okay, try again. Dear Yunus, I think you may log out and log in again, and then activate your microphone, because I can see that you're not able to do that now. Hello, hello, we have your voice.
Hello. Hello. We will talk about Internet of Things, my presentation. For the first time, Internet of Things is a new things for the Internet or for technology. So I chose this subject because I think all the future maybe contains of Internet of Things. Introduction. In recent years, the concept of popular by some so such as remotely monitoring intelligent set of tools. So this revolution is an important technology because it has a infrastructure of the internet with the concept of a more advanced computer network, where all the physical devices around us are uniquely recognizable and interconnected. With these involving technologies, everything around us, such as televisions, washing machines, and etc., can be interconnecting, and this connection is made through some useful information with the help of various available technologies. Therefore, it is exclusively follows the information to be connected devices, and based on this, automatic operation will be performed. Problem statement: the Internet of the potential for stability and future, but at the same time, its security is likely to be endangered depending on how to access these devices. Hackers can use these devices, no matter how well security companies think. There are types of ensure safety practices, which are done by making vulnerabilities are discovered in the because devices have an effect on users' lives. Safety tips should be priorities, and appropriate safety infrastructure should be used in a new system and designs. These limit the potential risk associated with accessible Internet of Things security. Things has 4 keys. First one, perception sensor, such as radio frequency. The purpose of this layer is to unique device and study the information from the real world with the help of relevant sensor. There is to transfer information collected from perception layer of the information processing systems through existing telecommunication networks, Internet of corrections such as the Internet, mobile network, or other valid networks. This layer is the middleware layer. This layer includes information processing systems that perform automatically based on the result of processing data, handling the system to a database that provides the storage capabilities of the collected data. This is several level and ensures the same types of services between connecting devices. The last is application layer. This layer identifies the realizes and the application of Internet of Things based on the need of users and different type of industries such as smart home, smart environment, smart transportation, and smart hospital. Internet of Things perspective. The purpose of the Internet of Things is to enable objects to connect anytime, any place with anything, and with any person who ideally uses any route, network, and any services. The Internet of Things and further enhance their intelligence by making or empowering decision making for the fact that they can communicate with each other and have access to information that is aggregated by other objects, or that they are complex. The internet and of physical objects that incorporate technology to communicate and sense or interact with their own internal or external interaction of efficient work protocols, improved sensor, cheaper processor, and points of startups and developing companies for the necessary management and functional software. Ultimately, all of these concepts form the core of the Internet of Things. The Internet of Things and service leads to the creation of integrated continuous network of entire monitoring processes that transform factories from operation environment to an intelligent environment. New services such as monitoring for the elderly and payment the use of services can emerge. For the government, it improves the convergence of data resources for planning across the country, promoting coordination between organization and facilitating faster response to accidents. It is and skills and cost to optimize equipment and resources. Cloud technology enables the global infrastructure to generate services, allowing anyone to create content and application for global. A network of objects connect and universally and also maintain the ICT that enable global infrastructure to communicate consumer, business, and industrial interests. Create a global people data objects. This convergence is a cloud connection for objects that senses and transmits a wide array of data, helping to create services that are not clear without this level of connectivity and analytical intelligence. The use of a platform is driven by technologies such as the cloud, objects, and mobile phone, and these technologies are used as a driving force for the use of platforms. Component of technology and devices. Intelligent system of which the Internet of Things is a part generally consists of three components. The first one is a sensor and aggregator. Locate data using GPS. Sensor is and airs using camera and microphone along with organs that can measure anything from temperature to pressure change. Components focusing on the technology and device connection. The input are located in, and the third one is the pupil and the processor. The input can be combined with two systems that integrate data, pupil, process, and system. The security for the internet, we previously speak about it, and I think the most things, large scale application and internet services are increasingly danger to disruption, attacks, or data theft. Advanced and needed secure Internet of Things, including dangerous good. DDoS and attacks. DDoS is a disk operation system, and DDoS activation was denial of service. And attacks are now well understood by the current internet, but Internet of Things is also prone to such attack. Special techniques and the mechanisms are needed to ensure transportation, energy, and urban infrastructure that cannot be disabled. General attack detection and recovery or resilience are required to confront specific internet threats such as station and at risk. Malicious code hacking attacks. Awareness of the cyber of tools or techniques that need to be involved in of things-based infrastructure that need to be monitored, managed, and advance needed to activate the operator in the line the Internet of Things protection through of the system and to assist operator in adopting the most appropriate security measures during attacks are among the most important. The Internet of Things needs to handle almost all modes of operation by itself and without relying on human control. A new technique and method are needed, for example, machine learning, which leads to self-managed Internet of Things. The challenge for Internet of Things is architectural structure. Internet of Things is stable throughout the entire period of time, and the security mechanism at every logical layer cannot implement a complete defense system. Is the challenge, and many research are needed to create a secure structure by combining control and information. While basic management is an important foundation of a secure mechanism, it was a hot topic of research. This is still the most difficult aspect of cryptographic security. At present, researchers have not found the ideal solution to this problem. Lightweight encryption algorithm or higher sensor node performance is still not applied. As a result, the large-scale sensor network always remains operational. Security rules and regulations is the third challenge. At present, security laws and regulations still are for Internet of is about national secure information, and privacy. As a result, our country needs to a legal perspective to develop Internet of Things rules and regulations undeniable needed. With the development of wireless sensor network, radio frequency pervasive computing technology, network of telecommunication technology, and real-time control theory, CBS, an emerging form in this system. High security is a sure system mentioned earlier. Security challenge for have been creating a sub-secure structure is also essential. Basic management in a real large scale sensor network has always been a challenge, and the rules of regulation in this which are related to Internet Things among the challenge. Neural network. To improve the Internet of Things, really we need to neural network. In the field, a number of a simple computational known as neurons are used, which are model of how a human brain cell works. Each neuron in the network sends input information after processing and converting it into output. Also, audience of the neurons. For the number that are connected form a structure of neural network. For this purpose, neural network used a predetermined learning algorithm because the neural network is initially created is while the algorithm behavior of neuron in the network neuron or in the words weight of action and correct it in order to perform the appropriate reaction to achieve the desired goal. Next, please. Training phase and operations. The first step in the designing a neural network is to teach the appropriate behavior to it, which refers to the stage or phase of training and is using a data set or teacher. Teacher means a mathematical function or a person that evaluates the quality of neural network performance and defines its value. In other words, it affects the weight of neural network neurons and desired goals. However, since the neural network is a complex application for which there are mathematical models, or the efficiency of neural network is often difficult. So, in most applications, data is used for training. After completing the training phase, the neural network is generating operating phase in operation. From this point, neural network is also training value for value and food value value approximated. Learning see that this recognize that the output one or another for the hidden layer. The hidden layer we cannot use it, and the output layer, which is the last layer, we can. It is used by the human, so as application or something. So there is a hidden layer, and we cannot recognize it, and we can also only see the input layer and output layer. This structure is contain three layers of it. Of things with a computer make all the physical devices around is uniquely identifiable and connected them to each other. The Internet of Things integrates by billions of smart devices that can communicate with each other with minimum human intervention. The deployment learning and artificial intelligence have significantly over the past few years in order to build a strong security solution as well the use of these security and systems. The next slide, please. Okay, the subject of the internet brings more comfort for example in the internet things can be good for having these security challenge. In addition to the security issue, objects they reference on for listening. That's it.
Okay, thank you for your presentation. But every student should bear in mind that we don't want to read through the text. Okay, you should say, you should talk with your own words. Okay, so try. If it's so hard for you to present in English, it's okay. You can use Arabic. But regardless of the language of your choice, you should present with your own words. Okay. Thank you all for your presentation. See you next week.
you.